Welcome back to C Square. In this lesson, we will talk about chords. Chords are segments of endpoints on the circle, and they divide the circle into parts. And you have here three examples of three chords. Okay, so, well, we have chord AB, which is called also the diameter, is the longest chord. It divides that circle T into equal parts, into semicircle, how we call them. And of course we have chord CD and chord EF. You can see chord CD here. Whenever you have chords like this, you have a minor and a major arc. So that is about chords, but let's see now some theorems that we can use when we discuss about chords. And you notice here, it says here CD congruent with EF, the arc CD in fact congruent with arcs EF. Is about these two arcs. If these two arcs are congruent, then these two segments are congruent. This is one way to see this theorem. But remember, if and only if, which is a very strong statement in geometry, a biconditional, how we call it, works backwards also, which means if these two chords are congruent, then the arcs are congruent. So this is the first theorem about chords and arcs. And now let's use that theorem and let's take a look to first problem. In first example, we notice we have two chords, CD and EF. We notice also they are congruent, they are the same, they have the same measures. So that means the arc CD and the arc EF are congruent. Let me write that right here. Arc CD and arc EF are congruent because the corresponding chords are congruent, which means the measure of arc EF, which we need to find out, is going to be the same with the measure of arc CD, which we know it's 132. So we have the measure of angle EF is 132 degrees, which means X is 132 degrees. Let's take a look to the second problem. The second problem we notice also we have two chords, MH and HP. They are congruent. Why? Because we notice the same marking there. So that means these two arcs, MH and HP, are congruent. So it's okay if I call this one also X. So now I'm going to write a statement which comes from these arcs. Arc MH, which is X, plus, so this arc, let me try to go on top of it, plus the measure of the arc HP, which is also X, plus the last arc, which is arc MP. If you add these three arcs, which is 134 degrees, what do we get? We get the whole circle, which is 360 degrees. So now we have to add the two x's, 2x plus 134 equals 360. We're going to have to subtract 134 on both sides. So we're going to have 360 minus 134. And that will be 226. And the last step, divide by 2, and we have x equal 130. Let's take a look to the second problem here, which very similar with the other one, but now we're looking and we notice these arc AB and these arc GH are congruent. We have the same sign on them. So that means the segment AB, the chord AB, congruent with the chord GH. Okay, so this is the converse of the previous theorem. So that means the segment AB is equal, the length of the segment, the measure of the segment AB equal with the length, the measure of segment GH. So that will give us an equation: 2x plus 8 equals 20. I'm going to subtract 8 on both sides. I get 2x equals 12. Divide by 2, we have x equal 6. Let's take a look at the second problem, and what do we notice here? We notice these two arcs have the same measure, 120. They are congruent. That means the corresponding chords are congruent also. So that will be my first thing to write here. I'm going to write chord VF is congruent with chord VP, which means the measure of chord VF is the same with the measure of chord VP. That will give us this equation, which I'm going to write it down here to have more space. 3x plus 5 equals 5x minus 15. And now there are different choices to solve. I personally prefer to subtract 3x on both sides. And I have 5 on the left side only equals 2x minus 15. Now I have to add 15. And I'm going to end up here with 20 equals 2x, and the last step, divide by 2, we get x equals 10. Another theorem that works for arcs and chords, it's right here. You notice in this picture I said if MN perpendicular on AB, and we see this right angle here, that means it's perpendicular, then AE congruent to BE. But I want you to notice MN is not any chord, is a special chord, is the diameter. Also, if this diameter is perpendicular on the chord, the arcs, AN in this case, and arc NB are congruent also. Okay, so this is the theorem. If a diameter or radius, it works for a radius also, of a circle is perpendicular to a chord, then it bisects the chord and its arc. Very important. Okay, now let's see how we use this theorem. In fact, here on the next slide you see the same theorem backwards. It's the converse that we need to be careful. Look at here on this theorem, we know that AE congruent with BE, the segments, and you see that in the picture. MN perpendicular on AB, then MN is the diameter of the circle. So that is the converse of the previous theorem. And as you see here, how it sounds, the perpendicular bisector of a chord, very important, perpendicular bisector means it's perpendicular and cuts the chord in half, contains a diameter or radius of the circle. So let's see some problem here, how we use the previous theorem. And we notice here we have AB equals 10. This is the diameter of circle M. GB is this chord is 8. We need to find this x. Now another thing that is very important to notice in the picture now is this MH is perpendicular on chord GH. That means these two are congruent. GH is congruent with HB based on the previous theorem we discussed about. And since GB is 8, that means either one, GH or HB, both of them in fact, are half of that, 4. One more time, MH bisects segment GB because it's perpendicular on that chord. So now also we can find out how much MB is. Let me put that 4 here. MB is the radius, and it's going to be half of this diameter of 10. It's going to be just 5. So now we have a right triangle there, which I'm going to draw it here. This is the right angle, that angle H, this is 5, and this is 4. We need to find this x. So I'm going to use the Pythagorean theorem. A squared plus b squared equals c squared. So in this case we have, you need to be very careful, the legs are x and 4, so we have x squared plus 4 squared equals 5 squared, x squared plus 16, 4 squared, and 5 squared is 25. I'm going to subtract 16 squared on both sides, so I'm going to get x squared equals 25 minus 16 is 9, and for finding x we need to take square root of 9. You notice I even put plus and minus because we're talking about the length of a segment, and that will be nothing else than 3. Let's go to part B, which is very similar. We need to find the value of x, this x here, which is the radius. In this picture the radius is tk. However, I do have a suggestion. Draw another radius, for example this one. Can I draw tv? That's also okay. Now let's take a look what is given to us. It's given to us that rv is 20. That is this chord. However, these two pieces are the same, they are congruent. Why? Because we notice this is perpendicular on this chord, so each of these has to be 10. And also we notice LT is 6. And like I said, this is also x because it's the same with TK is a radius of circle T. So now we do have a right triangle, which I'm going to draw it here. Okay, it's going to be something like this. This right angle is angle L, this is x, and we have the two legs, 10 and 6 now. So again the same theorem, the Pythagorean theorem, a squared plus b squared equals c squared, but now we know the legs, the a and the b, so we have 6 squared plus 10 squared equals c squared, or x squared in this case. So we have 36 here plus 100 equals x squared, or x squared equals 136. For finding x we need to take square root like in the previous problem, and now we need a calculator because we need to round it to the nearest tenth. So let me grab a calculator and do square root of 136. I end up with 11.66, so I round it to the nearest tenth, 11.7. And that is about this problem. Another theorem that is related to the chords and arcs, corresponding arcs. Again, you notice this strong statement, if and only if. Okay, so let's take a look what this theorem says. If we have here, I'm going to read it first to one way. If EF congruent with DC, if these two chords are congruent, then MH congruent with MG. These two segments are congruent. That means they are equidistant. If the chords are congruent, the chords are equidistant from point M. This is one way to see it. And also you can see it backwards, which will be if the chords are equidistant from the center, then they are congruent. That's what this theorem here says. So again, the keyword equidistant in this theorem. So let's see how we apply this theorem. So we need to find the length of each segment, justify your answer. So now we need to find RV, which is this segment here. And we know RQ, it's 12. Ladies and gentlemen, let's take a look to this picture, very important. We notice the chord LP is congruent to the chord FG. Why these two are congruent? Because we notice they have the same marking. If the chords are congruent, that means they are equidistant from the center. So that means simply VR congruent with RQ. So that means nothing else that VR is equal to RQ, which means RQ is, oh, RQ, we know RQ, we need to find VR or RV, I apologize. So which means RV is nothing else than 12. So again, if the chords are congruent, then they are equidistant from the center. That's what we use here. The same thing here if we look to part B, but I should have a right angle here, I apologize for that. We notice these two segments are congruent. That means, and also we notice this represent the distance from the center to the chords. So they are equidistant from the center. That means CD is congruent with AB. If they are equidistant from the center, then they are congruent. And now we need to find CD if AM is 12. If AM is 12, that means MB it's also 12 because TM bisect the chord. So that means AB will be 24, which brings us nothing else the fact that CD is 24. So these two problems I think are very easy, but the justifications in geometry and not only is very important. On my next problem, we're going to use the same theorem, and we notice very similar. We notice here that LP, this chord, and MG are congruent because we notice the same marking here, right? So that means they are equidistant from this center. So that means TF and FQ are congruent, or let's use what we have in the problem, FT is congruent with FQ. This is the justification. The chords are congruent, then they are equidistant from the center. So that means FT, the measure of the chord, FT is the same with the measure of the chord FQ, which gives us the equation that we need to start this problem for find the value of x, which is 3x plus 10 equal 5x minus 18. So I will subtract 3x here, and we have 10 equals 2x minus 18. Add 18 on each side to get rid of the minus 18. And I have 28 equals 2x divided by 2, and we have x equals 14. So this is how you set up the problem, but this part here is very important. This is the justification of this statement, why these two expressions are equal and we can solve the equation, because these two chords are congruent and therefore they are equidistant from the center. The last problem in this lesson is this one, when we have a circle and where NT it's equal to NC and it is 12. So we notice again NT and NC represent the distance from the center to these chords, and they are the same, they are congruent. That means the chords are congruent. The chord DL congruent with chord MG. So basically here one more time, I'm going to say if the chords are equidistant, they are 12 from the center, then they are congruent. So now I'm going to write here the measure of the chord DL, the equal of the measure of the chord MG. definition of congruent segment, and then we have 5x plus 15 equals 3x plus 37. Very similar with the previous equation. I'm going to subtract 3x now here, and I have here 2x plus 15 equals 37. Subtract 15 on both sides. And we have 2x equal 22, and divide by 2, we get x equals 11. So we finish part A. Now we can move to part B, the last part. This problem, find the radius of circle N if MG is 30. So we know now this segment MG is 30, and I'm gonna do two things here. First of all, I'm gonna draw this radius of circle N, and now one more time we look in this, and C is perpendicular on MG. That means these two segments are congruent. This and C bisect the chord since it's perpendicular, and since MG is 30, each of these pieces will be 15. So now we have this triangle NCG, which I'm gonna do it here. And we know this angle is angle C, right angle. This will be 12. This is NC, and this is going to be 15. This is the radius, which I'm going to call it X, just to use Pythagorean theorem. A squared plus B squared equals C squared. We use it a couple times in this lesson. So we have here 12 squared plus 15 squared equals x squared. So we have here 144 plus 225 equals x squared, and 225 plus 144 is 369. So x will be square root of this number, which is 19.2. The radius of this circle N is 19.2. I round this to the nearest tenth, and that's it. If you enjoyed this lesson, don't forget to click the like button. Come back and see square for more help. Thank you.